In 2022, Duffus and Morimoto reported that current conservation policies in the UK and Ireland overlook endangered insects and are taxonomically biased towards Lepidoptera. This was done by using a quantitative framework that assessed which insect orders are the most covered by conservation policies throughout the UK and Ireland, and whether these policies effectively covered the most threatened groups. All of these policies contain lists of species that are either considered highly important for conservation or are directly threatened by human disturbance or exploitation. The species within these policies were then compared with data from all the insect species found throughout the UK and Ireland, and then this was further compared with regional Red List data and data from the European IUCN Red List. It was found that Lepidoptera, specifically butterflies, received the most protection and policies, which you can see here represented in this graph, with Lepidoptera shown in red. While orders such as Diptera, Hemiptera, and Hymenoptera were found to be underrepresented. Various groups of insects were also found to be absent from policies, such as snakeflies, alderflies, scorpionflies, earwigs, except for one species found on the Scottish Biodiversity List, as well as the absence of thrips, book lice, and all but one species of flea. This graph shows the species which are threatened alongside their position in their priority lists. In Figure A, you can see that England's policies protects the vast majority of endangered butterflies, whilst there is substantially less coverage for the other threatened groups. In Figure B, Wales appears to show a similar trend to England's coverage, while in Figure C, Scotland appeared to have low representation across all the groups. In contrast, we can see in Figure D that Northern Ireland has a higher representation of threatened insect species across all the groups. Ultimately, these results indicate that not all groups of insect orders receive the same level of protection from policies, which could have further detrimental effects on policy enforcement involving insect conservation. So why is there this bias? Throughout Europe, butterflies are well monitored. As a result, there is sufficient data to promote their conservation, whilst many other insect groups lack sufficient data to enforce their conservation. Expert knowledge and scientific research are important for governing conservation policies and legislation. Therefore, one would think that this would have an influence on how many protective policies and overall funding there is for insect conservation. Is it possible that if more long-term data sets were available for other insect orders, that these underrepresented orders could be more incorporated into policies? It could certainly help. However, this study showed that policies throughout the UK and Ireland varied in their protection coverage. Therefore, this taxonomic bias is not necessarily due to more Lepidopteran species being classified as endangered. Previous research conducted by Leandro et al. In 2017 also found bias in protective policies. It was reported that butterflies, as well as dragonflies and grasshoppers, were overrepresented. Additionally, it was also found that insect species that were larger, had more multicolouring, and were more well known and widespread were also more likely to have protection status throughout Europe. Therefore, it could be that this bias is the result of societal perceptions towards more charismatic insect species, such as Lepidoptera, which could also be influenced by the fact that Lepidopterans are often used as an umbrella species for the overall conservation of insects, as well as indicators for habitat quality. So now the question is, how do we improve policy coverage across all threatened insect species throughout the UK and Ireland? For a start, priority lists should be formulated by addressing the ecological role of each insect species. This would ensure that all functional groups are protected. National plans and current strategies already put into place for pollinator conservation across the UK and Ireland should also expand out to include all functional insect groups, such as parasitoids or decomposers. In addition to this, the criteria for assessing extinction risks could also be adjusted. For example, in the absence of long-term population data, life history traits could be used to assess extinction risk. To improve long-term data sets across a diversity of insect species, population monitoring for all priority species across the insect orders should be made a requirement in conservation action and should also be encouraged among citizen scientists. Scientists and researchers who support these ideas will need political recognition to address these issues to implement these strategies. But do you know who else could help? Well, you. Citizen science aids in providing important baseline monitoring data. So by adding observations of all the insect species you find onto platforms such as iRecord or iNaturalist, you could also contribute to this long-term data set. This could provide valuable evidence for more insect species to support their red listing or incorporation into policies. Lastly, it should also be considered that this study excluded some policies that are relevant, such as agricultural policies, pesticide regulations, and protected area designations. Therefore, it is still unknown how effective these types of policies are for insect conservation, and this should be further investigated in future research.